Section 8.4, testing a claim about the standard deviation or the variance. In this section, we are discussing about the standard deviation, and the requirement is sample is a sample random sample. It has to be a random sample. What is important in this section is the population has a normal distributions. Must have a normal distribution in order to use the formula. And this is a formula we use in these sections. We are using table A4, and DF, degree of freedom, is n-1. So we have already discussed the formula for proportion of the z-value for proportion of numbers, and then mean, and then a standard mean, and then a standard deviation is the very last one that we are going to use here. Proportion, two formula for the mean and standard deviations. Again, what is important here in this section is population must have a normal distribution. This is a very strict requirement for these sections. Now, what we have here, we are using the table, they call it chi-square table, and the graph of a standard deviation is not a bell shape anymore. It's skewed to the right, and based on different value for degree of the freedom, you have a different shapes. So all the value in these sections are start from 0 and goes to the positive. When you go to the right is a positive. So the numbers always start from 0 and go to the right. The symbol that we are using on the horizontal axis is, it looks like an x to power of 2, but it's not something to power of 2. It's just a symbol that we are using. It's some kind of symbol like that. So there is a difference x2 distribution for each number of degree of freedom. So based on degree of the freedom, you have the different shape. Therefore, you have different x2. Now, how do I find the value? This is in case of two tails. Although tails do not look like they are equal, but they are. So the shape is not the bell shape and symmetric like what we had before, but the tails are having the same area. So here is, in this example, is 95% confidence level. So if this area's confidence level is 95%, then the difference of 1 minus 0.95, again, is 1 minus 0.95. It's 0.05, which is our alpha. And if we divide it by 2, would be 0.025. So that would be area of each tail. Now, in order to find these two values, one is x to the right and one is x2 to the left. And remember, since we start from 0, and as the number move to the right increase, this number is always greater than that numbers. So x2r has to be greater than x2l. So in order to do that, now we need to find the area to the right of this point, these two critical points. What area is to the right of that? It's just this shaded area to the right of this, which is 0.025. So then on the table A4, this is the chi-square table. On the top, you have area to the right of the critical value. Area to the right of critical value. So for that, you find the degree of freedom. And when you find the degree of freedom is 0.05, then you can find your table. So here I have 0.025 and degree of freedom is 9. So DF is 9 and this is 0.025. So here you just go 9 and 0.025. It gives you these numbers. 19.023. Okay. So you go to degree of freedom of 9 and 0.025, and that gives you that number, 19. Now, how do I calculate X2L? What is the total area to the right of this point? What are all these areas? You already have 0.95 and you add 0.025 to it. The entire area is 0.95 plus 0.025, which is 0.975, or from the total area, which is 1, you could subtract this 0.25. So either one, you could either from the total area subtract 0.025, that gives you this total here, or you could just take 0.95 plus 0.025 to find 0.975. So the second one is 0.975. The area is 0.975 to the right, and for the 9 give you these numbers, 2.7. That's how we get 2.7. Again, remember, the area to the right is 0.975. DF is 15. DF is 9. Then you got these 2 points. That's how you find X2R and X2L. Unlike tests and confidence interval involving the mean, which do not require normality when it is greater than 30, tests and confidence interval involving standard deviation require approximate normality. So it doesn't matter whether n is greater than 30 or not. In these sections, your graph must be, your population must be normally distributed. So on these examples, we give you a set of the numbers. These are listed below are the heights for the simple random sample of the female supermodels. And significance level is 0.01. Test a claim that a standard deviation is less than 7.5. So this is the claim. Claim is a standard deviation is less than 7.5. So based on that, then we know we have left tail, one tail, and is the left tails. One and the left tails. So the formula require n, which we already know how many numbers we have here, is 16 numbers. The formula need a standard deviation of population, which is given in the problems. It need a standard deviation of the samples. So we need to find a standard deviation of the sample for these numbers. And if you want to use your calculator, again, what you do is you take all these numbers and you put it in L1 on your calculator. So in that case, stat, edit. I already put these numbers on my calculator. So all I need to do is go to stat. After you put all the information in L1, go to stat. calculations. Already all the numbers in L1, so all we need to do is just to do the calculation. So S is 1.84. S is 1.4. Mean is 177.25, but we don't really need a mean here. We just look for standard deviation of the sample, which is given here. So in that case, when you have a standard deviation of the sample 1.84, you take that and you substitute here. So by calculations, you have 0.907. Now I need to find the critical point. This area, the significance level was 0.01. So if I subtract that from 1, what is remaining is 0.99. So area to the right of this point is 0.99. Area is 0.99 and N is 16. Let's go to the table. And for 16, which DF is 15, and 0.99, you have these numbers. So 0.99, the top, and DF is 16 minus 115, it gives you 5.229. So 5.229 is this point. Now, where does this fall? 0.907 fall into the critical area. Remember, when we fall into the critical area, we reject HO. Our X2 calculation fall into the critical area, we reject HO. When we reject HO means we accept H1, and H1 is original claim. Now, one thing we didn't mention in these problems, we didn't mention that the population is normally distributed. If function is not normally distributed, we cannot really use the formula, but it doesn't give it to you. What you could do, you already have all the numbers in L1. You could graph them. You could have quantile plot. So in order to do that, if you plot it and we see all the numbers are clustered around the straight line, then we know we can tell the function was normally distributed. So I already have all the number here. All I need to do is go to the second Y, which is a stat plot. Second stat plot. Make sure the first one is on, and we take the last graph. You see, it's already in the last graph. All the numbers are in L1, so everything is fine in this one. Then, now go ahead and graph. So after you see everything, now go on graph here. And if it's not clear, then you could use zoom stat. So you see that here numbers are almost on the straight line. So in that case, we conclude that all the numbers that are coming from normally distributed populations. Now, what if we want to calculate confidence interval? Confidence interval is from this formula. Again, what you need to do, you need to have X2L. This is in case of two tails, because in one tail you don't have that. In case you want to do the calculation, in case of two tails, this is the formula. So for that, and this is the process. If the significant level is 0.01 and it's two tails, and this is 0.98, how do we find X2L and X2R? Again, X2R is to the right, and X2L is what's the area to the right? Is 0.98 plus 0.01, or 0.99, or you could just say 1 minus 1.1.99. That's how you do the calculation using table A4. So to see how we calculate these two numbers, you could look at this table here. Now, when you use the calculation for the interval, you need to use this table here. This table, if you already know the significance level and whether your graph is two-tail or one-tail, would give you the confidence level. And the confidence level is when you use your calculator would ask for it. This problem is the two tails. See, here there are 20 samples, 20 aluminum cola and 20, and a standard deviation of the sample is given is 18.6. And the claim is use 5% significant level, this alpha is 0.45. Claim that all the can with 0.0119 have a standard deviation of 27.8. So the claim is that a standard deviation is 27.8. So since HO always take an equal sign, original claim is this. So what's opposite of that? H1. It's two tails. For each tail again. For this one, what's the area to the right? 0.025. For the second one, what is the total area to the right is 0.025 plus this one, or 1 minus 0.025. So that these two numbers are that. So calculations, you already have a standard deviation of population, samples, or standard deviation of samples, that give you 8.5. 8.5 fall into the critical area. Again, we reject HO. HO happened to be original claim. So first we find these 2 points, and this is a good area, and these two are critical area. So my number fall into one of the critical area, then we reject HO. Now, on the homework side, for the first page, what we have here on problem number 1 is the multiple choice. Problem number 2, these information are given. In problem number 2, the claim is that the standard deviation is less than 0.05. So it is one tail, and this is a left tail because it's less. Okay, so this symbol H1 determine the shape of the graph, which is left tail or not, or two tails or right tail. Now, N is given, a standard deviation is given, alpha is given. What is the area to the right? The crosshatch red is 1 minus 0.01. This is 0.99. So if you go to the table, area to the right, table A3, area to the right is 0.99. df n minus 1 is 26 because n is 27. That gives you 11.16, and that's this point. Now the calculations. Calculation, you already have S. You already have a standard deviations. You plug it in, 14. Now, where does 14 fall? 14 does not fall into the critical. 14 fall into the good area. So we accept HO, and we reject the claim. Now, we could also want to find the p-value. To find the p-value, you need to go to the calculator and do this. This is a function that you use on the calculator. So you go to second verse, go all the way to X2 CDF, it's number 8. And then the lower is always 0 because we start from 0. Upper one is 14.392. We want to find the area for this x2. And df is 26. So you put in these numbers. That gives you 0.033. And remember, if the p-value is greater than alpha, we do not reject HO, we accept HO. So p-value of 0.033 is greater than 0.01, which is the alpha. So these two must match. You accept HO based on this comparison. You also accept it based on comparison of the p-value. And the last section is a couple of multiple choice that I have the key here for you.